Hey guys, it's me, Miss Miller, and we're back again with Chapter 5, Section 3. I separated the section into two parts to make it a little bit easier to digest all the information. Some of this is going to relate back to the previous sections we did, so let's get started. One of the first things we're going to go over is given a point in the coordinate plane, we can evaluate trig functions based on the angle formed with the horizontal axis and the terminal side of the ray formed from the origin to the point. So if we look at the horizontal axis is going to be our initial side, our positive x-axis. And what's important here to see that the triangle that's now formed gives us an interior angle theta, or a reference angle, which we'll go over more in future videos. But the distance from my origin to my right angle is x, and my distance from the horizontal axis to my point is going to be my opposite side, y. And as we look at each point that is now formed within each quadrant, you're going to see that your horizontal axis, whether it is the positive x-axis or the negative x-axis, will always be your adjacent side x, and your height of the triangle will always be the opposite side, y. Same in your third quadrant. Now we're still using that negative x-axis as my side that I'm going to draw a triangle to make an acute angle, make a right triangle. But my adjacent side to that angle is x, and my opposite side is still y. We're using r as our hypotenuse. In future sections, we're going to start looking at these points making a unit circle, and that r is going to stand for the radius. But here it's still your hypotenuse of your triangle. Again, what's opposite? That y value, the distance to your horizontal axis is still y, and this is now x. This, I think, is a really informative photo for you. If you want to take a picture of it before we go on, or go back to it as a reference point, I think it's very valuable. So if we look, trigonometric functions of any angle when given any point. So in any quadrant, we're going to use this formula, r equals the square root of x squared plus y squared. That is just your Pythagorean theorem. You're saying your horizontal x, your vertical y squared equals the sum equals r squared, or you take the square root of the sum. Again, for any of these angles, if we take a look, the sine of theta is y over r, which makes sense. Here is my angle theta. What's opposite is y. No matter what quadrant I'm in, the opposite side will always be y over r. Cosine is now x over r, because x is my adjacent side to the angle and over my radius, or my hypotenuse r. And tangent is opposite over adjacent, so y over x. These are your excuse me, reciprocal identities. So cosecant to sine is now going to be r over y, which is your hypotenuse over opposite. Your hypotenuse over adjacent is secant, and your adjacent over opposite is going to be your cotangent. This is helpful. Not every time will you need to graph, but I wanted to try to show you what it looks like in the coordinate plane. So if I take a look and I graph the point P, I go -3, -5, and I graph that point right here, P. And if I use my origin, oops, I'm going to connect these two the best of my ability. Sorry guys, it's not the greatest. And here's my initial side. The triangle that then forms is from my origin to -3. So that's my x distance, -3. And -3 to my point is now -5, which is my y value. So when I'm evaluating my trig functions, I know sine is y over r. We first need to find out what my radius is, or my hypotenuse. So I have r equals r is going to equal the square root of x squared plus y squared. So r equals I don't know what's up with my pen today. R equals x squared, so negative 3 squared is 9, plus negative 5 squared is 25, and I get r is equal to the square root of 34. So when I evaluate what the sine of theta is, again, theta is this angle that's formed from this point in the third quadrant, we're going to get that we have negative 5 over square root of 34. We cannot leave this. We have to rationalize. So I'll end up with negative 5 square roots of 34. Over 34. My cosine is x over r, which is going to be negative 3 over the square root of 34. Again, we do not want to leave this, so we end up with negative 3 square root of 34 over 34. And tangent is our opposite over adjacent y over x, which is going to give us negative 5 over negative 3. That's going to simplify to a positive 5 over 3. This is important to note that notice both of these values are negative, but tangent ends up becoming positive, even though it's in the third quadrant, because it's the relationship of my opposite over adjacent, my y over x, both being negative gives me a positive answer. So now if we think of our reciprocal identity, we know that it's the hypotenuse r over y, the reciprocal of this, which will now give us the square root of 34 over negative 5. If you want to just call the whole thing negative, that's fine. The secant of theta is going to be r over x, which is going to give us square root of 34 over negative 3. And then our cotangent, which is going to be x over y, which is negative 3 over 5. Negative 5 simplifies to positive 3 over 5. Again, notice that cotangent and tangent are both positive here where everything else is negative. Now, not every time do you have to graph the point to understand what you're doing. I know that if my point 12, negative 5, that's going to be in my fourth quadrant because x is positive and y is negative. What I do know is I need to first find my hypotenuse. This is my x value. This is my y. So r equals, again, that square root of x squared plus y squared. So r equals the square root of 12 squared, which is 144. Come on. 144 plus negative 5 squared, which gives us 25. Add that together, and r equals the square root of 169, which is beautiful because we know that that equals 13. No need to rationalize. All right. Kind of in our way now, but so the sine is going to always be our y over r. And so our y value is negative 5, so I'll have negative 5 over 13. My cosine is x over r, right? Our adjacent over our hypotenuse, which is going to give us 12 over 13. And my tangent is going to be my y over x, which gives us negative 5 over 12. Notice what's interesting here is now cosine is what's positive and everything else is negative, which is interesting to know, and that we're in the fourth quadrant. So if I use my inverse identity, right, reciprocal identity, I know I have r over y, which is going to give us 13 over negative 5. My secant of theta is going to be 13 over 12, because again, that's going to be r over x. And our cotangent is now x over y, and so that will be 12 over negative 5. Notice again, the relationship cosine and secant are what's positive, everything else is negative. So this relationship in the past two is actually really important because trig functions can only be positive in certain quadrants of the four-quadrant plane. So we have this little image here. In our first quadrant, all functions are positive, which makes sense because our x is positive and our y. So every function, no matter what, will always be positive. But that starts to change when we go into other quadrants. So in quadrant 2, our x is actually negative and our y is positive. So the relationships that we just saw, sine and cosecant, have ratios with y and our hypotenuse, which is always positive. So when y is positive, sine and cosecant are positive in our second quadrant. In our third quadrant, both x and y are negative. And with that ratio, the only thing that can then become positive is tangent and cotangent because those are relationships of x and y. So a negative divided by a negative gives us a positive, which we just saw in one of our past examples. And finally, in our fourth quadrant, x is positive, but y is now negative. So the relationships where we have our hypotenuse and x are our cosine and our secant. An easy way to remember which ones are positive is an acronym that I was taught, which is all students take calculus. And we go in the order of how we count quadrants. So all of them are positive. Only the sine and cosecant are positive. The tangent and the cotangent are positive. And then C for cosine and secant. Those are your reciprocal identities. Those are what go together. Now your textbook suggests some other ones, which are all snakes tease chickens and a smart trig class. I've also seen all science teachers are crazy. So whatever works for you to remember it, but all students take calculus. All of them are positive, sine and cosecant, tangent and cotangent, and cosine and secant are positive in the fourth. Let's see how we can test out this knowledge, which is understanding where theta is going to lie in the quadrants based on certain information. So if tangent is less than 0, that means that the value of tangent is negative. So if we think of our four quadrants, 1, 2, 3, and 4. If tangent is negative, obviously that can't be our first quadrant, excuse me, because that's where they are all positive. It could be here. It can't be in my third because that's where they're positive. So we now narrowed it down to a choice of the second quadrant or third. So we now need to look. The cosine is greater than 0, so that's positive. So it's not positive in the second quadrant, but it is in the fourth. So which angle does theta lie? Theta is in the fourth quadrant. All right, let's do another. It's almost like a logic puzzle. All right, again, think of your four quadrants. All students take calculus. Sine is positive. Sine is greater than 0. If sine is greater than 0, that means it's positive. So sine is not positive in my third, not positive in my fourth. It's positive in my first and my second. So those are the only two possibilities, but now secant is less than 0. Secant less than 0. Secant is negative in only my second quadrant because it's positive in the first. So my second quadrant is where theta lies. All right, drawing a little image for yourself, kind of process of elimination allows you to figure out which quadrant. All right, now evaluating your trig functions. This gets where we're going to apply everything we've now learned into this unit. So the tangent of theta is negative 2/3, and the cosine of theta is greater than 0. So we know cosine is positive, tangent is negative. Automatically, we should know that that can't be in the first quadrant. It can't be in the third. And if cosine is positive, so our theta is now in the fourth quadrant, which is going to be kind of helpful to us as we move forward. Excuse me, guys. We want to, again, evaluate what quadrant this is in. Tangent's negative, cosine is greater than 0, so we're in quadrant 4. In quadrant 4, we know that our x, y, x is going to be positive and y is going to be negative. This is important when we look at the tangent of theta. Tangent of theta being is our y over x. In the fourth quadrant, y is what's negative and x is positive. So if we have negative 2/3, the negative gets put to the numerator, not the denominator. So I have negative 2 for y over positive 3. Remember, you don't distribute the negative to both. So that's really great that now we know x and y, so we can know that we can find r. So again, x is positive 3, y is negative 2. So let's find r in order to find cosine and cosecant. So I have the square root of 3 squared plus negative 2 squared. R is then going to give us 9 plus 4. So r equals the square root of 13. Cosine of theta. We know that the answer is going to be positive. The cosine of theta is x over r, so we have 3 over square root of 13, which is going to rationalize to give us 3 square roots of 13 over 13. So that's one answer. Now cosecant. Now you could use your reciprocal identity if you'd like, but we also know that cosecant is r over y. R over y is going to give us the square root of 13 over, and it's really important here, negative 2. It's important to keep the sign, and it matches up with the quadrant that you want. Cosecant is negative in the fourth quadrant. It is secant that's positive. Here's another example. Tangent is now positive, which is interesting. So that could be your first quadrant or your third quadrant. And this right here is going to tell you cosine of theta is now negative. So cosine is negative. That can't be our first quadrant, but rather our third. So we're in quadrant 3. And we know in quadrant 3, x and y are both negative. So if tangent of theta is 3 over 5, which is y over x, and both of these are negative, then negative 3 over negative 5, which we know to be true. We know that a negative over negative is positive, so x is actually negative 5, and y is negative 3. We use this information to find r. So we have negative 5 squared plus negative 3 squared. R is going to give us 25 plus 9. This is starting to look a little familiar. It's a reverse kind of the point that we had before. Before we had negative 3, negative 5. So R is still the square root of 34. We can't simplify that. So to find the sine of theta, we know that sine is y over r. So I have negative 3 over the square root of 34. We can't leave it like that. We have to rationalize. So sine is negative 3 square root of 34 over 34. And now secant of theta, which we know secant of theta is going to be r over x. So we have the square root of 34 over negative 5. Just please pay attention to the directions. A lot of students will jump right in and say, oh, my y is 3 and x is 5. It's really important to remember to figure out what quadrant it's in so that you get the signs correctly. All right, tune into our next video to see part 2.